Welcome again. Our next speaker is Danica Senicic-Vukovic. She is the data scientist at Vast Company, and she holds also masters in natural language processing, and she's really experienced in this area. So welcome on stage, Danica.
Hi, thanks for having me.
You're welcome. We're really pleased to have you on the Data Science Conference, and the stage is yours. I won't take much time.
So hello everyone, my name is Danica Senicic-Vukovic and I work at Vroom, and today I'm going to talk about how we've been using deep learning in computer vision to improve our used vehicles listings. But first, as an introduction, I wanted to say a few words about who we are and what we do at Vroom. So Vroom is a company whose mission is to change the way people buy and sell cars, and that is by moving the entire process online, meaning that you are able to purchase or sell your car online, and it will be either shipped to or picked up at your address. And I have another Vroom commercial here that also illustrates this experience.
I'll buy it.
Great, 11,000 like we agreed.
11 grand's a little steep, but I'll tell you what I'm going to do. I got $400 here in cold cash, and I got my Nana's wedding ring.
What?
You like ocean stuff? Fresh frozen lobsters. If you add all this up, basically it's 11 grand.
Never negotiate with strangers again.
Vroom offered 12,000.
Yeah, and I didn't have to haggle.
Sell your car entirely online on vroom.com.
So briefly, we are a consumer-oriented product company, and our goal is to leverage our scalable data-driven technology to bring all phases of buying and selling the vehicle online, regardless of where our consumers are. And as an additional note, as you had mentioned, Vast, in my introduction as well, in January 2021, Vroom acquired Vast, which is an AI and big data analytics company who has been collecting and analyzing data since its founding in 2005. And today we can proudly say that Vast has become the leading provider of data solutions for many of the largest global 1,000 businesses. So as a part of a brief technical introduction, this slide is a high-level overview of what the data we work with looks like. So this slide outlines how the data is organized in our system, and this scheme represents the data flow from the moment it enters the system until it's finally exploited in a desired application. So our data comes in either textual or image format, which is mostly unstructured, and it arrives in our data feeds, which are basically external sources of data. We then store it in our data pipeline, and then we work on the transformation process where we analyze it, normalize it, we clean it of potential errors, and we then store it in a structured way. All that with the goal of really obtaining high quality data, which is then further propagated to further steps in analytics and used as training data sets, which then leads to productionizing quality models and machine learning applications. So more precisely, the data we're going to talk about today are photos, which are incoming from all our external sources. And we're talking about completely unstructured data here, meaning we just receive a batch of photos attributed to each car listing, and these listings are showing up on an aggregator website. So an aggregator website in this case is a site that collects car listings from other sources across the internet and puts them in one place where users can access it and eventually purchase a car, while the aggregator website gets a fee. So this here is what one typical vehicle selling website looks like. So it has cars photographed at different angles. Sometimes there are photos in a listing like this one here that isn't even a photo of the car. And these photos have banners, texts, phone numbers, and websites. And since we are powering an aggregating website, which takes a fee for its services, this information would allow the customer to contact the dealer directly, and we want to avoid that. So when we click on a listing, we see a bunch of images, but in no particular order, and that order is different for each listing. So here we see this Honda photographed from the back, then we have some exterior shots followed by interior shots, and then back to exterior and interior, and this ordering is different for each listing. So ideally, what we would like to have on this website is sort of a uniform feel for each listing and without all the noise on the photo. So we would have photos of cars only, and of cars which are all in the same position. In this case, we want all cars to have this orientation where front of the car is pointing towards the right. So for the first listing here, we confirm that the orientation is correct, and then we go on and remove all this dealer information in the background, which is not very attractive, but more importantly, it may incite the customer to contact the dealer directly to purchase this car. And as I said, we want to avoid this. And for the second listing, we do the same, but we also need to identify a different photo of a car which is pointing towards the right. And for example, for this listing here, we need to find the desired photo, but we would also like to flag this one as a photo that isn't even a photo of a car, and eventually remove it from the listing. So on the left here, we have photos that we have now, and on the right are the photos that we would ideally have at the end of our photo processing. So to do all that, we first need to classify all the incoming photos. And what we did was that we carefully analyzed what type of photos we're receiving and which categories make sense to define as classes for the classification model. So we came up with a couple of dozen classes. For example, some of these are front of the vehicle, right side, front seats, steering wheel, transmission, etc. And we have the one category where we fit everything else, so what we didn't consider as a separate category. So then what we had to do was create a training set, and we've manually labeled tens of thousands of photos with those categories we've predefined. And then to further make the data set even more diverse as well as large, we've also used different augmentation methods to obtain the variations of each photo, like having one photo in a different color, have it be mirrored or rotated, well, obviously for the categories where that made sense. So once we had the data set ready, we've trained the model, and at the very beginning, we started with the CAFE framework, and then later on, we've transitioned to TensorFlow, and we've used Google's Inception architecture of a convolutional neural network. So main advantage of using a CNN here in the classification task is that the network is able to automatically detect features that make each category distinguishable without any human supervision. And that, compared to the manually crafted features in computer vision in the time before neural networks, just saves an enormous amount of time while also getting excellent results. And additionally, to speed things up even more, we've applied transfer learning by using a pre-trained model. So a model that was trained on publicly available ImageNet data. So when we use transfer learning, we use weights of a model that had previously solved a task similar to the one that we want to solve. And then we freeze the lower layers of the network, which refer to general features. And we train the upper layers that refer to more specific features. And in this case, general features are usually considered, for example, edges and shadows. So these very general features of an image, while the specific features are different categories and features related to interior and exterior of a car. And using such techniques has really shown to be very valuable in an industry context because it allows for a quick cycle of this iterative process where we go from having an idea, then training the model with a certain set of hyperparameters and a starter data set. Then we evaluate the model, and by shortening the training time, we allow ourselves to have more room to experiment with different sets of parameters. We go back to the data set, we tweak it a bit, we change it, we reevaluate our classes, and we try to reach high accuracy results. And after a certain number of these iterations, we were able to reach very high accuracy, and this allows us to confidently categorize our photos, which also then sets ground for further photo work. So now that our photos are automatically labeled, we are also able to order them the way we want. For example, now for this listing, we have this photo of a car pointing to the bottom right corner, then other exterior shots. And then we have interior photos in a specific order as well. And additionally, we can also conclude using the classification method that this car has an automatic transmission and that it has a rear view camera as a feature. So as I mentioned before, since we're providing these photos for an aggregator website, we want to omit the information that would cause any customer leakage for the website. Like, for example, what usually happens is that the dealers put their information like phone and website in these license plate slots. So our task here is to automatically detect that area and blur that information. And at first, we tried using the existing model, which was an open source one that detects and blurs regular license plates. But since this is in that area, but doesn't really look like a regular license plate, we didn't get good enough results. But we were once again able to use that model by applying transfer learning because we were trying to solve a very similar problem. And additionally, this was useful because in that case, the data set we wanted to add on top of it needn't have been too large as if we were starting from scratch. So what we did, we labeled a couple of thousand of these photos with dealer information plates. And this data set consists of the photos and an information for the bounding boxes for each photo's plates. So basically one photo would be associated with at least one set of 4 coordinates like those that we have here. And for this task, we've used the 4th version of the You Only Look Once, or YOLO, convolutional neural network that is used for object detection. So to sum up, we've used a model that was trained to detect regular license plates as a starting model for the lower layers. And then we've added our custom data set with the dealer plates to apply transfer learning for our specific task. And by doing this, we were able to achieve very high accuracy, and this model works pretty well. So as I previously mentioned, a successful classification model that we had in the beginning allowed us to set sound ground for further photo work. And that means that we were also able to really narrow down the set of photos where this dealer plate may be visible. So only photos of the front, back, or side viewing of the exterior of the car are processed with the object detection model, because we know that only in these positions these plates are visible. So in a nutshell, the model detects the area of the dealer plate and outputs these coordinates, which we then use to blur the designated area. And as a result, the car remains intact while we've blurred out the dealer information. And finally, since there is still a lot of information left on the photos, like this phone number here, or these banners that have all the dealers' contacts, and well, since we also aim to have this uniform look in order to have a better end user experience, we want to remove all the noise that is the background, and we want to keep the focus on the vehicle. So this final segment is still our work in progress, but the idea here is then to use semantic image segmentation to obtain masks of the vehicles and use those values to cut out the car from its background. So this semantic segmentation is also a well-known computer vision task, along with the classification and object detection we've talked about. And the segmentation in itself is also a classification task, in a sense that it classifies every pixel to a class. But unlike image classification or detection, segmentation models actually show some, let's say, understanding of the images, in not only saying, oh, there is a car in this image, but also pointing exactly where and what the car is on a pixel level. So in practice, to do that, we need to have such training data. So each photo of a car will have its respective pair of a mask of that car, like here. And also in practice, this data set is more challenging to create compared to our previous data sets, because it requires substantially more time for crafting it compared to a labeling task, because we need to draw the exact shape of the object first and then label it. But once this data set is created, it can then be fed to a UNet network that was initially designed to segment biomedical images, but has been successful for many other types of images as well. So as I said, this is our work in progress, but the expected output would be a binary black and white image mask of a targeted image, like here, which is then used to remove the background from the photo. So overall, the way we've processed our incoming photos was that we've used image classification to sort out the photos and reach the relevant ones in order to make more user-friendly photo ordering. On the classified photos, we've then applied object detection to detect the plates area and blur it, with the goal of preventing this customer leakage we've mentioned throughout the presentation. Photos will then be processed with semantic image segmentation to remove background and further address customer leakage, as well as have more pleasant user experience. So thank you for listening, and I just want to say special thanks to all my teammates and colleagues for their support and the feedback on this presentation. Vroom is also hiring, so you can visit our website for more information at vroom.com/careers. Thank you.
Thank you, Danica. At the moment, we don't have a question, so maybe you can give some like wrap up and say like some advice to maybe people who want to apply for your company. What will be the process, etc.
So obviously to visit the website and to look out for all the available positions. We work as a remote company, so it's available to everyone in Serbia, and obviously follow the instructions from there.
Thank you. Also, we have a question from audience from Katerina that says, "Can you share the slides?" But I think we will send the recording of the conference after the conference is finished. You will get the link to your email. So, thank you. Thank you at the moment. So, Danica, would you maybe like to like say some final remarks for the audience?
Well, these are the projects we've been working on for the long time, and I think a great part of their success is that VAST has been collecting data for a very long time. So most of the ideas that we have and that come up, we have an abundance of data ready to be used. On the other hand, it's a bit always a bit tedious because we have to do some manual work to label the data, to analyze it, to go through everything. But I think it's really nice to work in a data company that has so much data available.
I understand. Yeah, that's super important for sure, because people think that you can start building from synthetic data or nothing, but you need to just have the basis for it for sure. Okay, I really appreciate it. It was a pleasure to have you with us today, and thank you for sharing your knowledge. It's really a great contribution to the quality of the conference rank. Appreciate it, Danica.
Thank you for having me.
You're welcome. So our next speaker is going to start in 5 minutes, so stay tuned.